Okay, Mari Carmen is professor at the University of Alicante in our research group, Nanobiopol. In fact, she's the head of the research group, so she's my boss. So I should do very well. And of course, she's expert in extraction, valorization of products, biopolymers, biomaterials. She has been in charge of the Work Package 1 in this, as Work Package leader in this ECOFUNCO project. And some of the results that will be presented here will correspond to this work in the Work Package 1. And okay, she has the leader of some national and international projects in our research group. So if I don't forget something,
no.
Okay, you take the floor, please.
Thank you, Alfonso, for your kind presentation. Okay, good morning, buongiorno to everybody. Thank you for being here in this Saturday morning. Okay, I will try to adjust my time also to the presentation. So, as Alfonso introduced, I'm going to present some of the results obtained in the ECOFUNCO project related to the extraction of different agro-wastes in order to obtain, as you see here, lipids, antioxidants, and cutin by using microwave and ultrasound-assisted extraction. Okay, as we all know, this is the importance, let's say, of the valorization of agro-waste because they are low cost, they have high availability and are renewable. So it's important, as I said, as we all know, to have advanced valorization alternatives in order to give added value to the different compounds that can be extracted, in terms also to the circular economy approach. So in particular, if we consider the figures given by the FAO, the production of food waste by producers and consumers has increased dramatically, as you see here in this graph, in industrialized countries, and in particular, cereals, fruit, and vegetables are the main food waste produced around the world. In particular, regarding tomato, we can see here some figures as well regarding the production and also, more important, the tomato waste that are generated that is, let's say, currently used for animal feeding, composting, and discard in landfills. So, in the ECOFUNCO project, we considered that it was very important to give an alternative for valorization of this waste because they are a rich source of different natural bioactive compounds that you see here, for example, cutin, polyphenols, fatty acids, tocopherols, and so on. Also, we can consider other different agro-wastes, which are those coming from the apple pits and watermelon byproducts. And as you can see here, we have also an interesting, let's say, figure of waste that can be used in order to obtain pectin, protein, polyphenols, and in particular in the ECOFUNCO project, the cutin. So, the conversion of food waste into different valuable functional additives is very important and can be used in different biorefinery approach to obtain different chemicals and products. In the case of the ECOFUNCO project, they have been used to obtain active tissues and different coatings. The main challenges for valorization of food residues lies on the optimization of these efficient and sustainable extraction methods and technique, and in particular, it is very valuable to consider a cascade approach to, let's say, obtain the maximum number of added value compounds with the less steps as possible. So I'm sure that all we know that conventional extraction is very used but has some problems, such as the use of long extraction times, the increase in the possibilities of thermal degradation of the active compounds, and the use of a high amount of organic solvents. So some alternative green extraction techniques have been considered in the last years, such as those, as you see here, based on the use of supercritical fluids, pressurized liquid, microwave ultrasound, and subcritical water extraction, because they are well known to short the extraction times, use no solvent or low amount of organic solvents, and in particular have high selectivity and extraction yields. In this case that I'm presenting here, we have considered the microwave-assisted extraction that uses the microwaves as an ionizing radiation that causes molecular movement by osmigration and dipolar oxidation. In this case, it is very important to consider that the solvent should absorb this microwave energy so the process is say, bye-bye, can work. Okay. I am going to highlight that the differences between the microwaves and the conventional extraction, let's say, it's in particular in the heat and mass transfer, which, as you can see here, follow the same direction. Okay. On the contrary of the conventional extraction, this can improve really the extraction efficiency and also short the extraction times. In the case of the, by using the microwave, we can use different alternative equipments. We can use an open system working at atmospheric pressure or a closed system working at high temperature pressure, and also we can use the microwave-assisted hydrodistillation with sometimes a very few solvent or even no solvent are used. With this increase the sustainability of the process. Okay. Microwaves, it's very used because it has a uniform heating, reduce the losses of heating energy, has a high efficiency and high reproducibility as well. In the case of ultrasound, okay, the formation, growth, and implosive collapse of the bubbles in the liquid as a cause of the frequency use of the the ultrasound produce the ultrasound cavitation, with induce some physical forces that can disrupt the cell tissues and increase the release of the active compounds. In this case, we can use an ultrasound bath or an ultrasound probe or sonotrode, and in particular, the use of the configuration by using the probe or the sonotrode is better, as you can see here, because you can modulate the conditions used in order to prevent when we are using sensitive components that we have some degradation. So as a summary, we have used in the ECOFUNCO project the microwave and ultrasound as a greener alternative that could enhance solvent penetration and cell wall destruction, and also enhance the extraction yields, reduce extraction time and solvent consumption, and are, by sure, more environmentally friendly. Just to finalize the introduction, these techniques need to optimize different variables, so the best procedure to do that, let's say, is the use of response surface methodology and also design of experiments in order to optimize at the same time all these variables, and also we can study at the same time many variables. So this is a best procedure, as I said, in order to do as much as results as possible, and also the possible interactions of the variables, extraction variables, in a reduced time. Okay, so now I'm going to summarize the ECOFUNCO results. Here you have an scheme, let's say, of the experimental procedure. We have considered from tomato waste the peels separately, the peels to extract the cutin, and the seeds in order to extract the polyphenols and lipids. And in the case of the watermelon and apples, only the peels were considered for cutin extraction, all these compounds using microwave and ultrasound. Firstly, we will go for the optimization of the cutin extraction. Okay, considering the microwaves, you can see here the scheme of the experimental procedure, which mainly consisted of a first microwave heating, and then the solid obtained was discarded, it was filtered, the solution. We added an acid that could be an inorganic hydrochloride acid, or we even use citric acid in order to increase the sustainability of the process. Then, after different steps that you see here, we finally obtain the cutin and we freeze dry it. Here you have also the experimental conditions used by using sodium hydroxide. Regarding the ultrasound, here we optimize a cascade approach in order to not just obtain the cutin, but also other different compounds that can be very valuable and can be obtained by following this cascade approach. So, in summary, you see here, starting from the biomass waste that in all cases were provided by SICA, I don't want to forget it, we firstly perform an ultrasound-assisted extraction in 6 minutes by using sodium hydroxide, and then the liquid phase that we obtained, we perform a precipitation, obtaining a protein fraction, solid protein fraction, and also a solution which has antioxidant properties. If we can go again for the solid waste obtained by the first ultrasound extraction, we perform another one, in this case by using ethanol solution, and then we can obtain a solid waste which is very rich in cellulose, and hemicelluloses, and also obtain the cutin by precipitation with the exit. So if we compare both techniques that have been used for the different agro waste, you can see here the extraction yields. In particular, these cutin yields were higher when you use tomato and apple. So in principle, they can be more economic, valuable, let's say, to obtain the cutin compared with the watermelon. We also saw that this cutin was thermally stable because, as you see here, we didn't observe any degradation by using the TGA until 200 degrees in both techniques. Here we also perform a complete characterization by GCMS in order to study the different monomers that are present in these different agro wastes. As you see here, different main monomers are obtained depending on the agro waste used. So we consider that this information is very important because the composition of the cutin depends on the agro waste that we are studying. So now we are trying to perform additional experiments in order to increase the properties of the cutin obtained by doing other chemical steps, the polymerization, in particular to obtain better properties in terms of water barrier. But as I said before, I think there are very interesting results because not the cutin obtained from different agro waste, let's say, is not the same in terms of this composition. As I said before, in the case of the ultrasound, we develop a cascade approach and obtain not just cutin, but other valuable components. Here you can see some results for these soluble proteins, okay, that we obtain in the yield and the content, and also the antioxidant compounds of the first solution that we obtained in the first extraction that has a quite high content of polyphenolic compounds, and also, as you see here, it has shown antioxidant activity by testing for different methodologies. Regarding the polyphenols from tomato seeds, here you can see the experimental approach that we followed. We performed microwave and ultrasound-assisted extraction, and then we follow more or less the same procedure that you see here. We perform a centrifugation in order to separate some interferences by using ethanol, and then we concentrate it, freeze-dry it, and obtain, as you see here, a solid tomato seed extract, which was further characterized, in particular, to study the total polyphenolic compound content and also the antioxidant activity. We also optimize the different conditions that you see here, and both techniques have in common that we obtaining our best results, let's say, by using just 15 minutes, okay, and using a similar ethanol concentration also as you see here. Regarding the results obtained, as you see here, we saw that the extracts obtained by using microwave-assisted extraction have higher results in terms of TPC and also antioxidant content. And this is accordance with, if you see here, the damage produced after the extraction. Because if we compare this picture with this one, it is clear that the cell damage, let's say, it could be higher. So we think that this is to have these results, let's say. We also study the thermal stability of the extract. Both extracts obtained by microwave and ultrasound, as you see here, have high stability regarding or considering that they are polyphenols extracts, okay? So we could say that more or less they could be stable until 200 degrees. Also, we perform HPLC-MS study, and we saw that the main polyphenolic compounds that were present in both extracts were chlorogenic acid, rutin, and anengenin, which are really well known for their antioxidant properties. Finally, regarding the lipids from tomato seeds, We started with a microwave-assisted extraction, then we do a centrifugation as well, concentrate and obtain it a tomato seed oil, which was further derivatized in order to study the FAMEs, and which was determined by GCMS. Sorry, I forgot to say here that in this case we use a solvent, ethyl acetate ethanol, which can be considered a greener solvent because for the lipids extraction, usually, if you look in the bibliography, they use hexane, chloroform, and this type of solvents. Okay, so in this case, we think that this methodology also increases sustainability for the lipids extraction. After the optimization, we obtained the optimized condition that you see here, and in particular, I want to highlight the solvent and also the time, because in 10 minutes, we have the extraction. We study the major FAMEs present, and as you can see, they are here. And also, we saw that nearly 80% of the fatty acids obtained were unsaturated, which are considered, as you all know, healthy, let's say, fatty acids. And also, the yields that we obtained compared with other obtained in the bibliography were enhanced by using this microwave-assisted technique. Moreover, we also obtained antioxidant performance with this oil coming from the tomato seeds, in particular due to its high content on gamma-tocopherol, as you can see here. So I think this is also an interesting results, because we are not just obtaining a tomato seed oil which is rich in healthy fatty acids, but also has antioxidant activity as well. Regarding the ultrasound-assisted extraction, we try to incorporate different solvents that you can see here. Firstly, we also use the ethyl acetate ethanol as well as the microwaves, but as the results were not so good, we decided to try with other solvents. As you see here, different combination of hexane with other greener solvent, but in all cases, as you see here, the results obtained with the microwave-assisted extraction were better compared with the ultrasound. So I would like to thank also the ECOFUNCO partners involved in the project, and as conclusions, I think it is important that to consider microwave and ultrasound assisted techniques in order to develop and optimize more greener methodologies for the extraction of different compounds, not just the used and showed in this work, which are related with the ECOFUNCO project, but also other compounds that can be used as colorants, proteins, and many, many others. And just to finish, I would like to thank also my research group, with, you see, Alfonso here, Ignacio as well, and yesterday, and it was Cristina. And also, I would like to announce that we are going to host the Biopol Congress, which is, I don't remember, Alfonso, 2 years, no? That it's not 2 years and a half. And we expect to have our webpage soon with some information, but we have the dates, if you can check them. And we will be very glad if all of you, okay, could come to Alicante, because I hope we will have a nice weather in November, and all of you are invited. And that's all. Thank you very much. I think more or less on time.
Yeah. Thank you, Mari Carmen, for the talk and for the announcement. You saved myself to do it, so it's nice.
Yeah, we need to accelerate the information on the web.
So we have time for one question from the audience, please. No, good.
Just one. Okay, thank you very much for your presentation, Maria. Very interesting. So I'm very interested in these process intensification methods you have used to extract high-value compounds. But I'd like to know the scalability of these methods in view of the process of these large available biomass.
This is the key question.
I know.
In fact, okay, in the ECOFUNCO project, we have developed these procedures at lab scale, okay, but considering your question, yeah, they can be scalable. In particular, the ultrasound is more easily scalable. I mean, it's not so linear scalable as the microwaves, but it's easier in the sense that in the facilities or you have to incorporate, okay, it's easier. But we can find also some different equipments by using microwave at higher scale. So the answer is yes, it can be scalable. We are in this way trying to increase the scalability of our process, at least to, let's say, to produce some kilos, no more. But by sure, you can find some other bigger equipments to increase the yields of that, yes.
Okay, thank you very much, Maria.
Okay, so thank you very much, Fran. It's okay. So thank you very much for your talk.